So we'll go ahead and get started with section 13.6. And it's called solving polynomial equations by factoring. We've talked a lot about factoring in this class. I'm not going to go super slow through the factoring steps, but let me show you the major ideas. The first major idea is something called the zero factor property. And what this says is if one factor of a polynomial is zero, then the whole polynomial equals zero. So this is the main idea here. What we want to do is, first thing we want to do is start by making the polynomial equal to zero. Then the next step is we factor the polynomial. And then we set each factor equal to zero and solve. Let me show you some examples. We'll start with just solving the following. And let's say we have x times x plus 1 is equal to 0. It's already factored. What factor means is write it as something times something else. Well, that's the way this is written. So it's already equal to 0. It's already factored. What we do next is we set each factor equal to 0 and solve it. So x equals 0, x plus 1 is 0. And that's what we get. If we had just 3x times x minus 2 is equal to 0. Pretty much the same as the last problem. What we do is already factored. So we say 3x is 0, x minus 2 is 0. So dividing by 3, we get 0 here. Adding the 2, we get 2. So you can see those are very similar. What about if we had 2x plus 1 times x minus 3 is equal to 0? Just like before, we set the factors equal to 0 and we solve. Obviously, those are already factored. So let's take a look at problems where we have to factor ourselves. So x squared minus 12x plus 27 is equal to 0. For a problem like this, we talked about factoring. We're looking for numbers that multiply to be 27 and add up to be negative 12. We could use like negative 9 and negative 3. So factoring, we get x squared minus 9x minus 3x plus 27 is equal to 0. Cutting it down the middle, we take out an x and a negative 3. And we talked about how to factor in our previous lessons. So this time we get the factors ourselves, and then you set those factors equal to 0. Sometimes we have to do a little prep work. So if we had x squared minus 12x is equal to negative 36. What we could do is bring the 36 on the other side. And then factor. So numbers that multiply to be 36 and add up to be negative 12 are 6 and 6. Just like we talked about before, we factor by breaking up the middle term. Putting it down the middle. And setting those factors equal to 0, we get 6 and 6. We actually get a double version. So the difference with this problem was we had to make it equal to 0 first. Initially, we started by having the problem already factored, and we set the factors equal to 0. Next, we had to factor ourselves, and then set the factors equal to 0. For a problem like this, we make it equal to 0, factor, set them equal to 0, kind of thing. Question, Dean? Yeah, so this is actually called a multiplicity. Multiplicity of 2 just means that it's the same answer twice. And when you have an even multiplicity, what it does on a graph is it bounces. So for this graph, it would go to like 6 right here, and it would just kind of touch it. It wouldn't go through. If it was an odd multiplicity, this would just go through. Something like that. All right, good question. Dean said if it's the same root multiple times, doesn't it do something unique on the graph? And that was where we talked about multiplicity. If it's an even multiplicity and we go to graph it, it just bounces. Couple more problems. What if we had something like this? 3x squared minus 13x is equal to 10. Well, we have to make it equal to 0. And then we'll do the same thing we did before. 3 times -10 is -30. That's to add up to be -13. So this would just be -15 and +2. We'd get 3x squared minus 15x plus 2x minus 10 is 0. Factor this the same way we factored the last problem. Cut it down the middle. You take out a 3x, and we're left with x minus 5. Take out a 2, and we get x minus 5. So x minus 5 times 3x plus 2. And then we set those equal to 0 to solve. So x would be 5, and 3x plus 2 would be 0. So x would be -2/3. And one more, what if we had something like this? -4x to the third minus 10x squared plus 24x is equal to 0. Remember when we talked about factoring, what we do is we follow a list. First thing we do is we look to take out a GCF. And if the leading term is negative, we take out a negative. So in this case, what we could do is take out a -2x, and we're left with 2x squared plus 5x minus 7 is equal to 0. Take out a 2, it should be 12. Yeah. Thank you. And then it's already factored. So we said at this point, we set the factors equal to 0 and solve. So we get x would be 0 here. And this would be 2x squared plus 5x minus 12 is equal to 0. And then we factor that just like before. So it should be -24, and this would be 5. Numbers that multiply to be -24 and add up to be 5. Let's see, 8 and 3. So it's a +8 and -3. So it should just be 2x squared plus 8x minus 3x minus 12 is equal to 0. Cut it down the middle. You can take out a 2x and x plus 4. Take out a -3, x plus 4. And we just get x plus 4 times 2x minus 3. And then we could set those equal to 0 and solve. All right. Now, let's see, a couple other things to finish this out. Let's see. Fundamental theorem of algebra. Fundamental theorem of algebra just says that that you will get as many answers as the highest power of x. Let me show you what I mean here. What if we asked you to solve the following? Then we had x squared is equal to 4. What we want to do is we always want to make it equal to 0. So we'll make it x squared minus 4 is equal to 0. And remember, we talked about factoring special cases. This is x squared minus 2 squared. And we talked about factoring special cases. Remember, we talked about you had a squared minus b squared. This is just a plus b times a minus b. So the way we factor this is we would just say x plus 2 times x minus 2. Which just gives us -2 and +2. So that's that. And you see how it's x to the second? We're supposed to get 2 answers, and we did, right? What if we had x to the third is equal to x? First thing we do is we make it equal to 0. So x to the third minus x is 0. Then remember what we said we want to factor. We'll take out an x, the GCF of x. And then we set the factors equal to 0. So x would be 0. And this would be 0. We already talked about this is a perfect case, so we could do this. And it should just be x plus 1 times x minus 1. So x would be -1 and x would be +1 when you set those equal to 0. And then x is -1 and x is +1. One more of these. What if we had 2x to the 4th minus 6x to the 2nd equals 0? What we could do again, take out a GCF, take out a 2x squared. And we'll just get x squared minus 3 equals 0. When we go to set them equal to 0, how many answers are we supposed to get? 4, right? So we could divide by 2 here. But if you just say x, if you take the square root and you just tell me x is equal to 0, that's only one answer, right? So what we could do is we could just write this x times x equals 0 and have 0 here and 0 here. So technically we get 2 answers, they're the same one, right? So we call this multiplicity of 2. We talked about that word before. And then for this problem, we could bring the 3 on the other side and take the square root. Remember, we're supposed to get 2 answers out of this. So one rule that happens in algebra is whenever you take the square root of something squared, you get absolute value, which turns into plus or minus. So this will turn into absolute value, it's just square root of 3. And then that turns into just plus or minus the square root of 3. But we are still getting 4 answers. They're just maybe not as nice as the other ones. Yeah, question. Right. All right, and then the last type of example from this section is I'll ask you to write a quadratic equation that has the following solution. So let's say the solutions are 3 and -2. So the way that we do this is we kind of work backwards. So you know how in the last example, say if we had like, this is just kind of an aside here. What if we had x squared minus x minus 2 is equal to 0? You know how what we would do is we would factor. And then set the factors equal to 0 and then solve. And this is kind of like what we've been doing for the last half hour here. What we're gonna do this time is we're gonna go in the reverse order. So the way we do these kind of problems is if the solution's 3, we say x equals 3 and x equals -2. Then we want to make them equal to 0. Then we want to multiply the factors. To get our polynomial. And this would be the answer. So it's almost like we're working backwards. Yeah. So quadratic equation just means the highest power is 2. One more from this section. Is if the solutions were -4 and 5. We're just going to do it the same way. We're going to say x is equal to -4, x is equal to 5, bring them on the other side of the equal sign. And then multiply those factors. And our answer would just be x squared minus x minus 20 is 0.